morning, my dear students. Today we are going to discuss the topic called instantaneous speed or instantaneous velocity. In the last class, we have discussed about average speed and average velocity. So let's discuss the average speed and average velocity first. Let's say this is average velocity, which is equal to the total displacement divided by the total time taken. Alright. Imagine a body is starting from 0 seconds, reached to some distance of displacement after 4 seconds. The initial position is x1, final position is x2. Let's imagine. Initial time is t1, final time is t2. Let's imagine. Right? Let's consider the body is reached 200 meters from x1 to x2. In this case, average velocity is equal to total displacement. What is the total displacement? The total displacement, can I write x2 minus x1? x1 is 0 meter, x2 is 200 meters. Alright, x1 is how much? 0 meters. x2 is how much? 200 meters. So what is the total displacement here? 200 meters minus 0 meters. Alright, so that is why I can write it is x2 minus x1 divided by, what is the total time taken here? Total time taken is the time interval between initial point and the final point. Total displacement is what? Displacement interval or the position interval between initial point and the final point. Alright. So the total time I could write t2 minus t1. So from here, average speed or average velocity, if a body is moving in a straight line without turning back, what I could write, it is delta x divided by delta t. So remember, this is the formula for the average velocity or average speed. Right? So what is this? For average velocity or average speed. Now the topic is instantaneous speed or instantaneous velocity. Look at here, 0 seconds. 0 to 1 seconds, the body is traveling from here to here. 1 second to 2 seconds, it is traveling from here to here. 2 seconds to 3 seconds, it is traveling from here to here. 3 seconds to 4 seconds, it is traveling from here to here. The interesting thing is, at a particular time interval, so the speed or velocity of a moving object is called instantaneous speed or instantaneous velocity. Look at here. At a particular instant of time, that's the most important, instant of time. So there is no concept of interval here. At a particular instant of time, the speed and velocity of a body, that's called instantaneous speed or instantaneous velocity. Instantaneous speed, we take only the magnitude at a particular time. For example, in this case, at 2 seconds, right? So the body is moving with 20 kilometers per hour. So look at here, at 2 seconds, this is called instantaneous speed. What is it called? Instantaneous speed. If you add the direction to it, at a 2 seconds time interval, the body is moving with 20 km per hour in a particular direction, and this will become instantaneous velocity. You know, the speed will have only the magnitude, but the velocity will have both magnitude and direction. Alright, my dear students. At a particular instant, the speed or velocity of a moving body is called instantaneous speed or instantaneous velocity. And very importantly, this instantaneous speed you can find by using the speedometers in our vehicle. Speedometers. While moving in a vehicle, you can check the speedometer. Continuously, the reading will be increasing and decreasing. Okay, so that indicates at a particular instant, the speed of a moving vehicle can be identified by using the speedometer in a vehicle. So in the vehicle, there is an odometer also. Odometer is a vehicle in which we find the distance traveled by the body. We find the distance traveled by the body. Alright, my dear students. This is odometer and speedometer. I hope you could remember these all the things we have discussed in our basics. Now, let's try to express the instantaneous speed or velocity. This can be expressed in only single way. Listen to me carefully. The slope of, this is what speed or velocity, right? Slope of position time graph at a particular instant will give you instantaneous speed or instantaneous velocity. Clear? The slope of position time graph at a particular instant. About the graphs we will be discussing in the next session. About the graphs. Complete concept about the graphs we will be discussing later. Slope of position time graph at a particular instant will give you the instantaneous speed or instantaneous velocity. So this indicates, carefully see my dear students, at a particular instant. So at a particular instant, see here, listen carefully. A particular instant is added to this average speed. Listen. To this average speed, so you get instantaneous speed or instantaneous velocity. Listen, instantaneous speed or instantaneous velocity. How to add a particular instant to the average velocity? Listen carefully. What is average velocity? Let me say average velocity is delta x by delta t. Okay, let's start from here. Delta t is what? Time interval from initial and final points. But we don't want the total time interval t2 minus t1. We need at a particular instant, let me say that instant is here. At 2 seconds, for example. Right? We need at this instant. What is meant by this instant? So the time interval is very small. Yes or no? Clear? So this instant, at 2 seconds, exactly at 2 seconds, you can see the time interval is very less. Right? Time interval is very less. When in this small time interval also there is some displacement. There is some displacement. Carefully see. In average velocity expression, when the time interval is very small, right, you can say that is called instantaneous velocity. So simple. So limit delta t tends to be 0. Almost the time limit is very less. It is not 0. Almost when it tends to be 0. Right? When it tends to be 0 indicates it is very small. So delta t tends to 0 means a very small interval. This means at a particular instant. No confusions. At a particular instant. When you start your limits concept in your mathematics, you will understand about the limits. So what I am going to tell you is, when this delta t value is very small, then this average velocity is called instantaneous velocity. Look at here, this is called instantaneous velocity, and it can be represented with dx by dt. So what is your instantaneous speed or instantaneous velocity? Dx by dt. So this value can be represented as dx by dt. What is dx by dt? So that is the slope of position time graph at a particular instant. So this x is the position here. So what is x here? So this is position. What is this t here? Time. Alright, position and time. Where x is a function of time. Where x is a function of time. So this dx by dt, I can also write it like a d by dt of x, where x is position of, where x is position. Alright, clear? So this is about instantaneous speed or instantaneous velocity. So look at the expression, my dear students. At a particular instant, the speed or velocity of an object is called instantaneous speed and instantaneous velocity. Let's solve a few basic numericals on instantaneous speed and instantaneous velocity. Students, let's see a numerical. Given displacement x of an object as a function of time, as a function of time. How it is given? X is equal to 2t plus 3t square. See, x is a function of time. What does it mean? When time is 0 seconds, you can find x. X is equal to 2 into 0 plus 3 into 0. You get x value. When time is 1 second, so 2 into 1 plus 3 into 1 square. You get some x value. So that means as the t value is changing, x value is also changing. So I am writing here, as t value is changing, so definitely your x value also is keep on changing. So that is called displacement x is a function of time t. Right? Now, question is, calculate the instantaneous velocity of the object at t is equal to 2 seconds. Right? Exactly at 2 seconds, what is the instantaneous velocity? They are asking instantaneous velocity. Do not substitute your t 2 seconds here. Understand, most of the students do this mistake. They'll simply substitute 2 here, 2 into 2 plus 3 into 2 square. So that is not the answer. Okay. Now, the question is instantaneous velocity. What is the instantaneous velocity? Immediately you could recollect instantaneous velocity is dx by dt, my dear students. So this can also be written as d by dt of x. So I hope you have finished your differentiation in basic mathematics. So now I can write d by dt of what is x value here. X is a function of time, which is 2t plus 3t square. This I can also write it as a d by dt of 2t plus, I'm just expanding this one. So d by dt of 3t square, my dear students. So here two formulas are involved here. So those two formulas also I will mention for you. So So for your better understanding, d by dx of kx, where k is a constant and this will come outside, k into d by dx of x. D by dx of x will be 1, so that is k into 1, it is k. D by dx of x is 1. Now, d by dx of x, it is 1 already, I told you. D by dx of x is 1. D by dx of x square, my dear students. This is in the form of d by dx of x to the power n, right? So, I'll write here. D by dx of x to the power n is equal to n into x to the power n minus 1 into d by dx of, so whatever is here in the base, so that value we need to differentiate. So this is the formula for d by dx of x to the power n. So from here, if you solve, you will get d by dx of x square value is 2x. Okay, 2 into x to the power 2 minus 1, see 2 into x to the power 2 minus 1 into d by dx of x. So what I can write, 2 into x to the power 2 minus 1 is x, d by dx of x is 1. So d by dx of x square is 2x. Okay, clear? Now let's apply here. D by dx of kx, it is the form of d by dx of kx, it is 2 into d by dt of t, no confusions, plus 3 into d by dt of t square, alright. So 2 into d by dx of x, this is 1, alright, dx by dx format, dx by dx format. So dx by dx is equal to 1, alright, plus 3 into, what is d by dx of x square form? See here, d by dx of x square form, it is 2x. So here it is 2t. We are doing the differentiation with respect to the t, with respect to time, right? So now it is 2 plus 6t. What is that? Your velocity. That is velocity. So this is the velocity is a function of time here. Understand? So this is a velocity of an object. Velocity of an object is a function of time. So that you should not forget. Velocity of an object is a function of time. Okay. See here. When you change the t values, velocity is also changing. So that is what I wrote here. When t is changing, x is changing. That means x is a function of time. So when t is changing, v also changing here. So that means v is also a function of time. So in this case, we need instantaneous velocity at t is equal to 2 seconds. And let us discuss t is equal to 2 seconds. Then substitute here. So when velocity with t is equal to 2 seconds, it is 2 plus 6 into 2, right? So which is 2 plus 12, which is 14 meters per second. Okay. So at this particular time, the body is moving with 14 meters per second. That's called instantaneous time. Alright, my dear students. Right? So let's solve. Let us find instantaneous velocity. Right? Let's find instantaneous velocity at 2 seconds in all the cases, whatever I am telling you now. So in all these cases, when x is equal to 3t plus 2t square, when x is equal to 2t square plus 3t, when 3t cube, when x is equal to 3t power 4 plus 2t, the fourth one, when x is equal to 2t cube plus 3t, right? So, and the fifth one, when x is equal to 2 plus 4t to the power 4, right? So in all these cases, you can find instantaneous velocity at t is equal to 2 seconds. And this is the class work, my dear students. This is the class work. All right. Let's concentrate on the acceleration part now. Let us discuss about acceleration, right? Listen. Average acceleration and instantaneous acceleration. So this is our topic now. So I'm not going to focus more on the acceleration part because those things are covered in detail in our basic sessions. Average acceleration, generally we call this as an acceleration, right? What is acceleration or average acceleration? Let's see. This acceleration is rate of change of velocity. It's called acceleration, rate of change of velocity. Now the average acceleration, look at here, the acceleration is equal to change in velocity divided by time. The average acceleration, when you write, it will be, look at here, acceleration, which is average total change in velocity divided by total time taken. So this is called the average acceleration. Now carefully, if you see, this is the average acceleration. I can write it is total change in velocity. I can write it is v2 minus v1 by total time. It is t2 minus t1, so that I can write delta v by delta t. Keep it like this. This average acceleration or acceleration will have the SI units meter per second square. Meter per second square. SI units of acceleration. And this is the acceleration which is a vector quantity which has both magnitude and direction. And this acceleration may be positive or negative or zero. Three values are possible. When the positive, negative and zero are possible, I'll tell you with a simple example. A body is starting from point A with some 50 meters per second, reach to the another point B with an acceleration A 60 meters per second. Acceleration means what? Increase in the speed. Yes or no? Acceleration means increase in the speed. Okay. Now, in a time, let's take 10 seconds. What is the acceleration here? Change in velocity by time. See, acceleration is what? Change in velocity by time. What is the change in velocity? 60 meters per second minus 50 meters per second divided by time, 10 seconds. So I can say it is 10 meters per second by 10 seconds, which is 1 meter per second square, and this is called acceleration, which is positive value. So let us reverse this condition. A body is starting with some 60 meters per second from point A. After some time, it reached to 50 meters per second. As the speed is decreasing, and here this A is called deceleration. What is this? Deceleration. When the speed is decreasing, this is called the deceleration. And here this is also represented with the symbol A only. Look at here, A. In same 10 seconds it has happened. Imagine A is equal to final velocity minus initial velocity. 50 meters per second minus 60 meters per second divided by 10 seconds. So can I say it is minus 1 meter per second square? So the same acceleration, we have got it as negative, so that is called the deceleration. So acceleration can be positive or negative, and it can be zero also when the body is moving with constant speed, right? Look at the interesting thing. So body is starting from A with 60 meters per second. After 10 seconds also, the body is found moving with same 60 meters per second. What is acceleration here, my dear children? Acceleration is change in velocity. So numerator 60 minus 60, it is 0. Acceleration is 0 meter per second square. So if a body is moving with constant speed, the acceleration is 0. Constant speed or uniform speed or uniform motion, right? The body is moving with 0 acceleration. Okay. Now, this is about acceleration. This is about average acceleration. Let's concentrate on instantaneous acceleration. And before moving to that, the slope of a velocity time graph gives you acceleration or average acceleration. No confusions. Acceleration or average acceleration. The same thing. The slope of velocity time graph at a particular instant, see here, at a particular instant will give you instantaneous acceleration. What is that? Instantaneous acceleration. So that you can write limit delta t tends to 0 of average acceleration. See here, of average acceleration delta v by delta t. So delta v by delta t. So this can be written as dv by dt. Okay, dv by dt, where v is velocity, t is time, and here the velocity is a function of time. The velocity is a function of time. Alright, my dear children, velocity is a function of time. So you can find the instantaneous acceleration at a particular instant, at 2 seconds, at 3 seconds, at 4 seconds, you can find it. Okay. Now, let us solve a few important and basic numericals of instantaneous acceleration. Let's see the given example here. Given example is given velocity v is a function of time t. The expression is given v is equal to 2t raised to 4 plus t square. Find the instantaneous acceleration at t is equal to 2 seconds. So simple. Let us see. We have instantaneous acceleration. Immediately you should recollect dv by dt. So this I can also write a d by dt of v. So this v, whatever you're writing here, that must be the function of this t. And this is a d by dt of v, 2t to the power 4 plus t square. Again I am writing you, my dear students, I am just expanding the term d by dt of 2t raised to 4 plus a d by dt of t square, right? So here the formulas I am using here, a d by dx of kx, which is equal to, k will come outside when k is constant, that is number. K will come out and that will be d by dx of x. D by dx of x is 1. So k into 1, which is k. Again I have written here because I have seen from all these years 99% of the students will suffer in application of differentiation and integration. That is why in basic mathematics you covered, and here also I am writing the formulas, then explaining the numerical as you are the first PUC student. When the time goes on, see, each and every chapter will have the differentiation and integration topics. As we move on in the further chapters, so like this the discussion won't be, remember. So directly the formula is applied in this expression and solve the questions. So here, and another d by dx of x to the power n, which is equal to n into x to the power n minus 1 into d by dx of what? D by dx of whatever is mentioned here. So d by dx of x. Okay. So d by dx of x is 1. So n into x to the power n minus 1. Right? These two formulas only used here. 2 will come out, and this is d by dt of t raised to 4 plus d by dt of t square. 2 into d by dt of t raised to 4. 4 into, see, that is d by dx of x to the power n form, n into x to the power n minus 1 into d by dt of t plus this is d by dt of x square. So this is 2 into t to the power 2 minus 1 into d by dt of t. So in detail I have mentioned 2 into 4 into t cube into, this is d by dt of t is 1 plus 2 into t to the power 1 t. So d by dt of t is 1. See here, 8t cube plus 2t. So what is this? This is acceleration. Now the acceleration is a function of time. Understand? So this acceleration is a function of time. I'm writing here. So the given acceleration is a function of time. So instantaneous acceleration you can find at a particular second. At t is equal to 2 seconds according to the given question. See here, find the instantaneous acceleration at t is equal to 2 seconds. At t is equal to 2 seconds, you substitute this here. Acceleration is equal to 8 into 2 cube plus 2 into 2. So this is 8 into 8, 64. Sorry, 64 plus 2 into 2, it is 4. So this is 68. Acceleration, and the time is given in seconds, and definitely SI unit of acceleration only you need to mention here, which is meter per second square. And look at here, my dear students. So this is how you can solve the instantaneous acceleration numericals by using differentiation. Okay. In the next classes, you will understand the applications of integration also. See, these are the applications of differentiation. Applications of integration also you will learn soon, right? And before that, some class work questions I'm just giving you here. You start solving. Find the instantaneous velocity, instantaneous acceleration. Instantaneous acceleration at t is equal to 2 seconds only. Okay, so given velocity is a function of time in this way, velocity is 2t plus 3t square. So velocity is 3t plus 2t square. So velocity is 2t to the power 4 plus 3. So velocity is 3t raised to 6. Look at here, 3t raised to 6 plus 2t plus 1. Right? For these 4 expressions, you find instantaneous acceleration at t is equal to 2 seconds, my dear students. And this is also a class work. Clear? I hope you understand this. So when you understand this is the class work for your better understanding of application of differentiation, right? So try to do that. All the very best for your online assignment.